Hello there, it's Jay here from Jay's Vintage Junk, and today we're back on with this thing. Now, if you've watched my channel for a very long time, you may have seen this before. I actually have done two previous videos on this bench power supply, but that was all the way back in 2018. Bit of a recap on it. I picked this up years and years ago. Essentially it's a very late 1960s bench power supply, dual bench power supply. So we've got basically a bench power supply there, and it completely mirrored on that side there. It's got some nice features on it for what it is. One thing I really like, the fact it's nice analog meter scales rather than the more modern bench power supplies, which are all digital. It's got a 30 volt output on it. It's got up to 2 amps output, and it's also current limited, so it does have a current limit feature on it. So it's really useful for playing with stuff where you're worried that if you go over a certain current, you're going to fry something. I'm thinking early ZX Spectrum, you're messing with that kind of thing. With this, you could set that to 900 milliamps or so. You're not going to have any problems. That's one of the main reasons I want to get this working, is for the current limiting feature on it. Now, essentially, this side of it basically works. This side of it, I think it's that way around. Yeah, it is. I think this side actually basically works. This side here is dead. That said, the reason I stopped the repair on this all the way back when I did in 2018 is, even though this side is essentially working, it's not usable when you actually scope the output. In fact, I'll quickly demonstrate here. We connect the old voltage meter. I've got that set to 20 volts, 20 volt scale. We'll connect up to the outputs on the power supply. We'll power that on. We'll switch the output on. As you can see, I'll probably just tweak that up, and it's actually fair. Even the scale is fairly accurate. We're showing 5 volts there, 4.87. We've got a fine tune to get it absolutely bang on. So it really is, like I say, it's quite a nice analog dual voltage power supply. So the trouble is, you have got a load of ripple on that DC there that's coming out of it. It's not smooth DC. The voltages look good and everything, but it's full of ripple. You can't really use it, and the reason is it's the big main smoothing cans inside here. Now, find a suitable screwdriver. In fact, let's get that unplugged. Let's be safe. Screws out. I must have taken this off the top as well. They certainly built things better back when this was made. Right. And it weighs a ton, I will say that as well. It's not a light piece of equipment. There we go. I should have the top off. And we're in. Now I think we can get this back piece here down so we can actually get to the root cause of this. So yeah, when I take them 3 screws out there, I'm pretty sure I can hinge this entire back panel down. This has got all the big power transistors on it and the heat sinks for them. And the main fuses and things like that. They've all been checked, you know, previously. Right. There we go, we're in. I don't know if you can make it out, but that's the issue. Basically, all of our main smoothing cans, and apparently from your information I found online, it's very typical of these particular bench power supplies that the original main smoothing cans here basically dry up. You can see, let me zoom you in, see if you can actually see it. You can see the spewing out of every single one of them. There, and there. Now this is our working side. Let's just turn that back round. Yeah, this is our working side here. I'll get you out a little bit. And as you can see, even though it's working, there is stuff. I mean, that one's not quite as bad, but it is really spewing the goo out there. And all I want to do in this particular video is get this side fully up and running. The reason I stopped working on it when I did back when I was originally working on it, one, I didn't really need a current limiting supply for what I was messing about with at the time, and I've got another little variable bench supply. I don't know, you've probably seen it in my other videos down there, that little micro reg there, which I've used for years and years and years and years. It's brilliant. It's not current limiting though, and it only has a 500 milliwatt output. Sorry, milliamp output on it. I really wanted something with a little bit more output and with the current limiting feature. That's why I want to see if I can get this working. I said the reason I stopped was these cans are really expensive. They're 2,200 UF at 63 volts, I think. And when I was trying to price them at the time, I couldn't justify basically buying them at the time. However, a few years ago, again, if you watch my channel a lot, you'll remember I bought the old control computer from a 1980s scanning electron microscope, and I turned the actual console itself into a monitoring desk that's actually on the other side of my workbench here. But I stripped anything that was useful out of it, and I got a lot of very high quality capacitors. And I was looking through here the other day and I realised I got a couple of these. Now what we've got here, these are Nichicon Temicom, really high quality electrolytic capacitors, and these are 2,200 UF at 100 volts. So the right capacity, they were slightly over on the voltage rating, which is absolutely fine. You can always go up a bit on your voltage rating. You can never really, unless you really know what you're doing, go under on the voltage rating that was originally used. The other thing is, this is a triple can. So in here we've got 3 2,200 UF 100 volt capacitors. These ones on here are single, so that's a 2,200, that's a 2,200. So what I can do, I can basically install one of these. I can actually use all 3 and go up on capacity. Again, it depends on where it is in a circuit, but this is the main smoothing on the output of the circuit. A little bit more capacity there isn't going to do any harm. It's just going to make the output that little bit less, even less ripple than it would have anyway. So what I'm planning on doing, let's get the old soldering iron switched on there. I'm going to pull these two cans out there. I'm going to put one of these in to replace it. Now, as you can see here, the way it's wired up, both cans there are in parallel. So basically, that's dropping. If you put them in parallel like that, you're going to double the capacity, aren't you? If you put them in series, yeah, if you put in series, you would halve the capacity. If you put them in parallel, you're going to double the capacity. So that's basically acting like 4,400 UF. If we add all three together, we're going to have what, 6,600 UF. Again, it's all in the main smoothing, so that's not really going to be an issue. I think that's probably going to be our best port of call, actually. I'm looking on here, all I can see is one possibly dodgy electrolytic on the main board there, which we'll have a look at, see if we want to swap that out. Apart from that, I can't see we need to do anything to this side, so we can get this side of the power supply up and running, and then we can look at working. In fact, we'll get that cap swapped out at the same time, but there are other issues on that board. Depending on how long I make this video. I weren't planning on making it too long, to be honest, because I've got an awful lot on at the moment. I don't know how actually sporadic my videos are going to be for the future. I'll say that to my viewers now. Yeah, I've got rather a lot I'm doing at the moment. To be honest, actually, I'm right in the middle of retiling my bathroom, which is a bit of an odious task, but I need to get done. I'm about halfway through that. In fact, I'm making this video because I wanted a break from tiling. Right, we'll get that disconnected there. I can pull those two cans out and we'll have a proper look at them. So essentially what I'm doing at the moment, like I said, I'm retiling my bathroom. I'm in the process of trying to sell one of my properties, one that I have rented out, which is becoming rather stressful, shall we say. When you've got a property with a sitting tenant in it, it's quite difficult to actually sell. It's causing me rather a lot of stress, so I'm having to work through that at the moment. So like I said, I'm doing videos and doing a lot of this type of work on a little bit on the back burner while I get some other things sorted out. And once I've done all that, I'm looking, once I've got that property sold, I need to throw a load of money at this property that I live in, because I want to sell this one as well. And to be honest, I want to move because I'm not happy where we currently live. It's not like it used to be, shall we put it that way. And there's a town close to me where I would much rather be living. Well, it does mean putting rather a lot of work in, like I said, selling another property, getting this property into tip-top condition, be able to sell this, and that would just about give me enough money to buy a property where I want. Right, I think we're free there. In fact, I've let that one drop out and should have really kept that in there, but let's see if we can sneak these out now. There we go. Yeah. And they've got a date on them. The Airy brand, 2200 UF, 63 volts. I was hoping they may have had a date on them, but these don't seem to be dated. But you can see the spew on that one. That one might, I mean, it started to spew, so it's not good, but that one's definitely not very well. Now, I dropped something down there, didn't I, when I was working. I've got the nut and the bolt there. Oh, it was a split washer off that. Damn. Let's see if we can find that before. If you ever drop something in a piece of equipment, and it's especially something like this that's got a lots of voltage in, try and get it back out before you power the thing back up, because you just know it's going to short across two things and cause you problems. Right, there we go. Got that out. Right, back to where we were. Right, so let's put that back in. Let's take one of the new capacitors. If I put it, yeah, it should reach, shouldn't it? 'Cause I'll need them two to there. Get that to there. So if I put that in, obviously it's a lot smaller, the new capacitor, than the old one, but we should be good. And I forgot that little washer. Just a sec, I need that little washer. Put the little washer on. There we go. Right, there we go. I'll tighten that up. Yeah, so basically big changes, hopefully afoot for me. In fact, I've been trying to move for a couple of years now, but it's getting to the point where I keep thinking it's now or never. You know, I really want to get a move on, but before I can, like I said, I do have to sell that other property, and unfortunately the tenant that's been in there has been in there for a long time now and really doesn't want to move, and that leaves me trying to sell the property with a tenant in it, which, like I said, is not easy. Right. Get that on there. The slight problem is that these new capacitors are actually designed for PCB mount, and obviously we're mounting them chassis mount style like that, but you can, generally speaking, you can get away with it. I've got away with it many times in the past. What we do need to do though is link all three of them sections together. We could, if it was a problem, just use two of them, but because I know this is on the output, I'm quite confident that it's probably going to be better having a little bit more capacitance than was already there, so that's why we're doing this. I'll take a little piece of wire and we'll go around the little tabs. In fact, I'll need a little bit more than that, I think. There we go, that should be enough. There we go. I'll zoom you in when I've done this anyway, and you can have a look what I've done. We'll go in. Make sure we get that soldered on there. Solder on there. And soldered on there. Right, okay, let's cut off the excess there we don't need. this is where I realise I've left my really good sharp side cutters up in the bathroom because I was using them to trim the plastic trim for around the tiles. Damn it! Hopefully we can do it with these ones here. Right, there we go. So we've got all three sections connected together there. So like I said, we're higher than we was. The original capacitance on them two cans there connected in parallel, which is basically exactly what we've just done there. It's 4,400 UF. With the way we've done that, we've connected all three together, we've got 6,600, but it's really not going to be an issue that. Like I said, that little bit of extra capacity on the output is, you know, it's not going to cause an issue. It's just going to make the output a little bit smoother. There we go. So basically that side I'm reasonably happy with. What I am going to do though is just check that capacitor there. That I think is the only electrolytic left in the actually in the circuit. We've changed the main smoothers. All the rest of these are small electrolytics. Sorry, small foil capacitors. I don't think any of them are going to be an issue. Like I said, that is the only possibility. It does look a little bit green on the top there. So how am I going to do? I have to take the whole board apart just to change that one damn capacitor. I bet I do. In fact, I wonder if we can test it in circuit. Use my ESI tester. We might be able to test it in circuit. Got a little ESI meter here. Right, there we go. Connect that to there. What size is our capacitor? That's the point. It's a 63 volt one at 47 UF at 63 volts. So let's read in. So it's 47 at 63, 0.90, and it's 0.09. So that's fine. There's nothing wrong with that capacitor. I wonder if we can do anything this big. I'm not sure. 4700 we can do. So we could test them both together. I go on there. I go on there. ESR equals 0.0 at 63 volts. Yeah, I think they're open circuit. I shorted. I don't think they're very happy. I'll put them on the capacitance meter and see what capacitance they've got left in them after. Right, so I'm reasonably happy with that side. Let's go and have a look at the other side. So this is the side that doesn't work. I didn't do anything. Oh right, it's the same board, it's just upside down for some very strange reason. Two up there, hang on. Capacitor down there, that's not down there. How bizarre, it's the same board, it's just upside down. So that's that capacitor we've just talked about. Now this side definitely does have something, like I said, something wrong with it because we've got zero output on it. But what we can do, in fact what I'll do, I'll just quickly swap out that capacitor exactly the same way as I've done that, then we'll come back and we might have a look at just doing some voltage checks and see if we can find anything that's different between the two. So back in a sec. Right, okay, we're back, and as you can see, we now have two of them capacitors installed. I'll just get you in a little bit so you can have a quick look. As you can see, like I said, we've got the ground there connected to the original ground point, and then we've just linked all three of the sections together and connected them. So it's very similar to how these capacitors were connected. Interestingly, if you notice, these are the second two that are pulled out. These are the first two. If you look at the bottom, these second two, these were getting hot. These were getting really, really hot at some point. That's why that plastic shrunk back on them. So that may have been down to why that side has failed. What I have just noticed is we've got fuses on the back. Let's check them fuses. Oh no, I think we're there. Let's check them fuses. We know that the mains input fuse, which I think is this one, is good because the unit actually powers up. But let's just check. If we can get in to test it. On there. Something. There we go. That one works. That one works. And that one doesn't work. It wouldn't be that simple, could we? Let's get this this section screwed back up in place. It'll make life a little bit easier for getting to the rest of it. I'm sure I don't want to trap any wires while we do this. There we go. It's these ones inside. Right, so it was that one there that we weren't getting any. I don't think that is actually the fault, because those are on the output and the meter wasn't moving or anything. So I do think we have got another fault with that channel. But said I did want to do a massively long video today. We'll just quickly try checking that fuse anyway while we're in here. That's a tiny little thing. I don't know if I've got any of them. Let's just make sure it is the fuse that's bad and it's not just like the holder or something. No, the fuse is fine. So the holder must be iffy. Unless it just wasn't in tight enough. Let's was it just not in enough? I don't know. Because the fuse is alright. Let's try it again. Now we wish I didn't screw the bottom of that back on, but never mind, I think I can get to it. On there. There we go. This one was the one that was alright, weren't it? Yeah, this was the one that we checked before and it was okay, so it should still be okay, shouldn't it? Connect onto there. Yeah, that's good. So we had a loose fuse. All we've done so far is change them bad smoothing cans and tighten a loose fuse. Let's see Yeah, so that's the one that's working. That's the one that wasn't working. Let's plug back in. We'll switch on. We're off. We're off. Don't know where we're set about there. Switch. Oh. Oh. Are we working? By Jove, I think we're working. That's the side that always has worked. This is the side that was dead. That looks good enough to me. That's our fine and coarse adjustment. Let's see whether we've got an output from it. I can just shove them in the end, we'll be alright. So let's put, say, let's put 15 volts on there. Let's set that, we'll set it to 20 volts there. Can you see that? I don't know if you can even see that, you know. Let's get you down a little bit. There you go, you can see that, can't you? We'll go on there. We'll flick the output. There we go, 15 point, that's not bad that, 15.12. 13, yeah, about right. So that was always working, like I say, it was just them smoothing bands, but this side was always dead. Let's do the same. That's our cut fine, that's our course. Let's get it to 15 on there. Let's go into our outputs. Yay! There we go, 14.97. Excellent. Let's try the. Can we get? Yeah. Fine, works. Brilliant. So that was an easier fix than I was expecting. Yeah, well pleased with that. Let's take that out. Let's get the case back on this. I was expecting more of a repair on that side. To be honest, I've even printed the service sheet out for it. I was pretty certain, you know, we had a bad transistor or something like that on that side. I knew it needed new smoothing cans, but I thought there was more at fault than there. It looks like it was just the smoothing cans and yeah, a loose fuse. Never mind, we'll take it as a win. Let's get the case back together. Now I know some people like making their test equipment, you know, look like new and everything. I'm not really for that, providing it's functional. It's not all beaten, you know, totally beaten up. I'm quite happy with it. Come on, you go in there now. Ooh. Why are you not like? Oh, there we go. Because you have to pull it to get it to line up. Hopefully that's right. Get you in there. Lovely. Get these screws back in here. Oh, very pleased with that. I was expecting that to need a little bit more work. Especially, like I said, especially on that side. I knew that was going to be easy. I knew all it needed was them smoothing cans changing. But that other side, I was expecting us to have to fight that a bit. In fact, I was planning on making just one video on, you know, just doing the caps on there. And then doing another video on fixing the other side, but looks like we're not going to have the pleasure of that. I do have another supply that needs some repair work actually. We could see about getting working. In fact, I've got loads of things on the to-do list for making videos. Like I said, the problem is I'm just mad busy at the moment with trying to sort the house out. Like I said, sort my sale out and sort out some renovations on this place. Once I've finished the bathroom, I've got a... Have I put that on the right way around? Have I put that on the wrong way around? Oh no, I think it's right. Yeah, it must be right, because that wouldn't line up right otherwise, would it? And them screws wouldn't line. Yeah, it's got to be right. Yeah, so there we go. That was not as much of a repair as I was expecting. I am super pleased with that. It's certainly going to be handy on the bench. I will retire my little micro reg there, and this can go in its place. And I think it will just sneak underneath my speaker at the end there, my soundbar that I have across here. I think it will just sneak under there. I'll probably have to move this monitor I have there, and it'll go next to my oscilloscope. So anyway, I hope you enjoyed that video. Actually, hopefully it's not going to be too long, this one. I know it was not like a major repair or anything. It was something incredibly simple. Hopefully I will be getting at least a couple more videos out, but like I said, bear with me, because like I said, I do have a lot on at the moment. As soon as, like I said, as soon as I've finished that bathroom, I've got to start on the kitchen. And then I've got one of the bedrooms to sort out, and then I've got a lot of stuff to move, and this is before I even get round to, you know, I've got windows to have changed. I need to save money up for that, and I need to sell that house before I can do that. And yeah, it's stressful at the moment, so like I said, people will have to bear with me for a bit. But anyway, hope you enjoyed watching that little video, and I will say thanks for watching, and goodbye.